At precisely 5:17 a.m. UTC on April 14, 2026, the Johnson Space Center in Houston was operating under routine conditions, continuing its role as the central command hub for humanity's return to the lunar surface. Inside the main control room, Flight Controller Marcus was carrying out a standard telemetry review from the Orion spacecraft integrity as part of the Artemis II mission. It was a procedure he had repeated countless times: system checks, environmental monitoring, and verification of stable orbital performance. For Marcus, it was supposed to be one of the quietest phases of the mission. The spacecraft was passing through a routine communication blackout period while rounding the far side of the moon, blocked from Earth-based signals by nearly 2,000 miles of lunar terrain. During this short window, nothing unusual was expected. No communication, no external disturbances, just stable data waiting to reconnect. Marcus leaned back in his chair, adjusting his headset while taking a sip of lukewarm coffee, eyes fixed on the slow stream of incoming telemetry. Everything appeared normal. The mission was on schedule. Systems were stable. There was no indication that anything unusual was happening beyond the moon's horizon. But that moment of routine observation ended abruptly. As the automated optical navigation system began transmitting its first burst of raw photometric data from the Hertzsprung basin on the lunar far side, Marcus froze. The coffee cup stopped halfway to his mouth. His attention locked onto the screen, where the expected dull, gray imagery of ancient lunar terrain was replaced by something entirely unexpected. Instead of a lifeless impact crater, the feed revealed localized bursts of high-intensity light emerging from beneath the regolith. These were not reflections of sunlight or sensor noise. They were structured emissions originating from below the lunar surface. Within seconds, additional instruments began confirming the anomaly. First, external thermal sensors aboard Orion registered a sudden spike consistent with a controlled plasma discharge. This was not typical lunar heating behavior. The signature resembled an organized energy release, not a random geological event. Second, the spacecraft's inertial navigation system detected a subtle but measurable gravitational dip as it passed over the same region. This indicated a localized mass density variation, something that standard lunar geological models cannot adequately explain. Then came the most alarming observation. As the camera angle shifted to capture the origin point of the flashes, the system recorded a precise geometric formation, 6 distinct points of light arranged in a perfect hexagon. The pattern remained stable for exactly 12 seconds before disappearing completely, leaving no residual thermal or optical trace. At that moment, Marcus reacted immediately. His training took over. He moved from passive observation to emergency protocol execution. His headset slipped from one ear as he leaned forward, rapidly inputting commands to secure and archive the data before the spacecraft exited the communication blackout zone. Without waiting for supervisory approval, he triggered a secure, high-priority transmission to the Lunar Reconnaissance Office. His voice was unsteady, but controlled as he reported what he had seen. The data, he confirmed, did not match any known meteoroid impact, surface reflection, or sensor artifact. The signals were originating from beneath the moon's surface. Inside Mission Control, the atmosphere shifted instantly. Conversations stopped. Screens were rechecked. Multiple analysts began reviewing the incoming feed simultaneously. Within moments, silence spread across the control floor, not the calm kind, but a heavy, uncertain silence driven by the realization that something unexpected had just been detected on a world long considered geologically inactive. The moon, which had been treated as a stable and lifeless celestial body for billions of years, had just produced a structured energy signature. And then the situation escalated further. Marcus received confirmation that the Department of Defense had begun reclassifying the Artemis II data stream transferring it to a restricted server environment. That single action changed the tone of the entire operation. This was no longer just a scientific observation. It was becoming a security-level event. And as analysts attempted to reconcile the data, one question began circulating through the room, unanswered and increasingly urgent. What kind of subterranean system produces a perfectly structured hexagonal energy pattern on a body believed to be completely inactive for 3 billion years? The implications were no longer purely geological. They were foundational. And what the team would uncover next would challenge not only lunar science, but the long-held assumption that the moon has been completely inactive for billions of years. Because once the initial shock of the hexagonal light pattern began to settle, the focus in mission control shifted from reaction to analysis, and from analysis to something far more unsettling: interpretation. At Johnson Space Center, engineers and astrophysicists began replaying the Artemis 2 telemetry frame by frame. What they found only deepened the mystery. The flashes in the Hertzsprung basin were not random bursts of energy. They were structured, repeating signals that appeared to follow a consistent timing pattern before vanishing. This was no longer a simple anomaly. It was behaving like a system. To understand the significance, researchers turned to photometric analysis, the science of studying light intensity and wavelength to determine its source. Under normal conditions, lunar surface flashes caused by micrometeorite impacts produce chaotic, multi-spectrum bursts. They scatter light unpredictably across wavelengths, consistent with high-speed collisions in a vacuum. But the signals captured by Orion's instruments did not behave this way. Instead, they showed uniform energy output, stable temperature signatures, and most importantly, directional coherence. That combination is not associated with natural impacts. It is associated with controlled energy discharge. As one senior analyst quietly noted in the room, the data resembled what theoretical models describe as engineered plasma emissions. Meanwhile, independent systems began confirming the same conclusion from different angles. Gravitational mapping tools detected an unusual anomaly beneath the Hertzsprung basin. The region showed a localized distortion in the moon's gravitational field, as if a concentrated mass or dense structure existed below the surface. This was not consistent with known mascon formations, which are typically irregular and diffuse. Instead, the reading suggested something far more organized, something compact, stable, and deliberately structured. At this point, researchers began comparing the data against historical lunar models developed since the Apollo era. Those models had always described the moon as a geologically dormant body with no active internal systems, but the new findings did not align with that assumption. Instead, the data pointed towards something entirely different: a hidden structure, possibly artificial. To explore this possibility, scientists applied advanced theoretical frameworks, including the Kardashev scale, as popularized in modern astrophysical interpretation. Within that framework, the energy signature observed beneath the lunar surface could align with the waste heat patterns of a Type 1 or even Type 2 civilization structure. That interpretation immediately changed the tone of the discussion, because if accurate, it would mean the moon is not just a natural satellite, but a constructed or modified environment embedded with advanced energy systems. Further complicating the picture was the gravitational dip recorded by Orion during its pass over the basin. This was not a minor fluctuation. It indicated a localized mass anomaly, strong enough to alter the spacecraft's inertial readings, yet with no visible surface structure to explain it. This contradiction forced scientists to revisit an older but controversial idea: that mass concentrations, or mascons, might not simply be dense mineral deposits, but could represent engineered stabilizing structures embedded within the lunar crust. At Harvard, researchers reviewing the Artemis 2 dataset reportedly expressed concern that the observed gravitational behavior does not match any known natural formation process. Instead, the data suggests controlled mass distribution, as if the interior of the moon has been intentionally organized. This interpretation led to a more complex hypothesis, that the Hertzsprung basin may not be a crater at all, but a functional node within a larger subsurface system. Some researchers began referring to it cautiously as a potential energy hub, and when the hexagonal flashes were reanalyzed in this context, a new theory emerged. The six-point pattern was not random. It appeared synchronized, as if part of a broader signaling network operating beneath the lunar surface. This raised a difficult question. If the moon contains a structured internal system capable of emitting coordinated energy pulses, then what exactly is that system doing? One theory, still highly speculative, suggested that these pulses could be calibration signals, messages exchanged between subsurface nodes to maintain alignment or operational stability across a vast internal network. In other words, the moon might not be inactive at all. It might be operating. And if that is true, then Artemis 2 has not simply entered a passive observation zone, it has crossed into an active environment. At this point, Mission Control was no longer treating the data as a curiosity. Security protocols began tightening. Data streams were being mirrored, archived, and in some cases restricted from wider access. Because the implications were becoming unavoidable. If the lunar far side is hosting an organized energy system, then humanity's return to the moon is not an arrival. It is an intrusion. And the next set of telemetry would suggest that whatever lies beneath the lunar surface is not only aware of Artemis 2, but is responding to it in real time. Because as Mission Control continued parsing incoming data, the pattern of anomalies began shifting from passive signals into active behavior. At exactly 7:56 UTC, additional readings from the Orion spacecraft confirmed that the gravitational distortion beneath the Hertzsprung basin was no longer static, it was changing. Subtle fluctuations in mass distribution were detected, suggesting movement or internal reconfiguration deep below the lunar crust. This was the point where scientists stopped treating the anomaly as a fixed structure. Instead, it began to resemble a dynamic system, and that distinction changed everything. The spacecraft's trajectory data added another layer of concern. As Orion crossed the 756-mile threshold above the lunar surface, its navigation systems recorded a barely perceptible deviation. On paper, it was just a few millimeters of shift in projected path. In practice, it indicated that the local gravitational field was no longer behaving uniformly. Something was influencing it. What made this even more significant was the absence of any visible cause. There were no surface eruptions, no seismic activity, and no external gravitational disturbances large enough to explain the deviation. The moon itself appeared unchanged on the surface, but beneath it, the data told a different story. At Harvard, and within NASA's internal analysis teams, researchers began comparing these readings against predictive models of lunar mascons and subsurface density structures. The conclusion was increasingly difficult to avoid. The gravitational field in the Hertzsprung region was not simply irregular, it appeared engineered in its precision. This raised a difficult question that no one wanted to state directly at first. If the structure beneath the moon is responsible for these shifts, then it is not inert, it is active. Meanwhile, a second development added urgency to the situation. The hexagonal energy flashes first observed earlier were no longer isolated events. Instead, they were repeating in a broader pattern across the lunar far side. The spacing between pulses suggested coordination, not random discharge, not impact scattering, but synchronized emission events occurring across multiple points within the same region. At this stage, scientists began referencing more advanced theoretical frameworks, including models that treat planetary bodies as potential information processing systems. Within that context, the hexagonal geometry becomes especially important. Natural formations rarely produce perfect geometric repetition at energy scales like this. But engineered systems do. And that is where the interpretation shifted again. Some researchers began suggesting that what Artemis 2 was witnessing was not a single structure, but a distributed network beneath the lunar surface. A system composed of multiple nodes, each potentially responsible for localized energy activity, all coordinated through some unknown mechanism. In that scenario, the Hertzsprung basin would function not as an isolated anomaly, but as one component within a larger operational framework. This interpretation also provided a possible explanation for the gravitational behavior. If mass distribution is being actively managed across multiple subsurface points, then the gravitational field would naturally appear unstable or dynamically shifting from an external perspective. But even that explanation raised further questions. Because if such a system exists, it has remained completely undetected throughout decades of lunar exploration. Until now. At Mission Control, analysts began overlaying Artemis 2 data with archival readings from past lunar missions, including Apollo-era gravitational surveys and more recent lunar reconnaissance orbiter maps. What they discovered was subtle but important. The Hertzsprung basin had always shown slight inconsistencies in its gravitational profile, but those variations were previously dismissed as sensor noise or low-resolution mapping errors. Now, those errors appeared to form part of a larger pattern, a pattern that only becomes visible when viewed with higher resolution instrumentation. At this point, the working language in mission control began to shift. Terms like geological anomaly were quietly replaced with subsurface system behavior. The distinction mattered. One implies nature, the other implies function, and function implies intent. This is when a more unsettling possibility entered the discussion. If the lunar far side contains a structured system capable of regulating energy output and gravitational fields, then its interaction with Artemis 2 may not be incidental. It may be responsive. And that leads directly to the next development. Because shortly after the latest gravitational fluctuation was recorded, the spacecraft detected a new type of signal, not light, not heat, but resonance. A low-frequency vibration traveling through the hull of Orion itself, as if something beneath the moon had begun to ring in response to its presence. And what engineers realized next would completely change the direction of the mission analysis, because the vibration detected in Orion was not random noise or structural stress. It was consistent, rhythmic, and eerily structured, as if the spacecraft itself had become part of an external system. At 9:03 UTC, onboard sensors confirmed that the low-frequency resonance was not originating inside Orion. It was being transmitted through space, passing through the vacuum, and interacting directly with the spacecraft's hull. The signal had no visible source, no electromagnetic precursor, and no identifiable wavefront structure in traditional sensor readings, yet it was undeniably present. This forced engineers to reconsider the environment around the lunar far side. The assumption had always been that space between Earth and the Moon was a passive medium, empty, predictable, and governed by well-understood gravitational and electromagnetic laws. But this signal did not behave like anything produced by known natural processes. Instead, it behaved like a field response, as if something massive beneath the lunar surface had entered a state of activation triggered by Orion's proximity. And then came a second observation that escalated the situation further. Telemetry from the Deep Space Network showed that the gravitational field over the Hertzsprung basin was no longer just fluctuating, it was organizing. Data points that previously appeared random now aligned into repeating spatial intervals, forming a structured lattice-like pattern across the region. This was the first time scientists began describing the phenomenon as a geometric gravitational structure rather than a simple anomaly, because the pattern was too consistent to be accidental. At the same time, spectral analysis of the earlier hexagonal flashes was revisited with higher resolution filtering. What emerged was unexpected. The light pulses were not just geometric in shape, they appeared to be temporally synchronized with the gravitational fluctuations. In simpler terms, light, gravity, and resonance were now behaving as a unified system. This level of coordination is not observed in natural celestial mechanics. It suggests coupling between different physical domains, something more aligned with engineered systems than random geological activity. At Mission Control, this realization caused a shift in how the data was being interpreted. Scientists began moving away from isolated explanations and toward system-based models. Instead of asking what each anomaly meant individually, they began asking how all anomalies were interacting together, and that produced a far more complex picture. The hexagonal light bursts, the gravitational dip, the subsurface density variations, and the structural resonance in Orion were all part of a single interconnected pattern, a pattern that appeared to be responding to external stimuli, specifically the presence of the spacecraft. This led to a critical hypothesis. The Hertzsprung basin may function as an active sensing or response node, capable of detecting and reacting to nearby objects through multi-layered physical channels. In that framework, Artemis II was not simply passing over a lunar crater, it was interacting with a responsive system embedded beneath the surface, and the system was reacting. Meanwhile, analysts at NASA and collaborating institutions began reviewing long-term lunar datasets again, this time with a new assumption, that the Moon may contain operational structures hidden beneath the resolution limits of earlier missions. What they found added historical depth to the current event. Subtle inconsistencies in gravitational and thermal data from decades ago began to align with the present-day anomalies. Areas previously labeled as sensor inaccuracies now appeared as low-level echoes of the same pattern being observed in real time by Artemis II. This suggested continuity, not a newly activated system, but a long-standing one that has been present, stable, and undetected for far longer than humanity has been capable of observing it clearly. At this stage, some researchers cautiously introduced the idea that the Moon may not be a passive celestial body at all, but rather a regulated environment with internal systems designed to maintain long-term stability and interaction capabilities. That interpretation, while still highly speculative, offered a potential explanation for the structured nature of all observed phenomena. But it also introduced a far more serious implication. If the system is active, and if it has been stable for millions or even billions of years, then its response to Artemis II suggests that human presence may represent a significant deviation from its expected conditions. In other words, the spacecraft may have triggered something that has been dormant or at least unengaged for an extremely long time. And that possibility changed the entire tone of the mission. Because shortly after this conclusion was discussed, a new reading came in from the lunar far side. And this time, it was not just a signal. It was a coordinated structural response that indicated something beneath the lunar surface had moved beyond passive observation and entered a fully active state. At 10:41 UTC, multiple instruments aboard Orion confirmed a synchronized shift in both gravitational and electromagnetic readings over the Hertzsprung basin. The changes were not isolated, they were simultaneous, occurring across different sensor systems with exact temporal alignment. That level of synchronization immediately ruled out random environmental noise. Instead, it suggested coordination across multiple physical domains. Gravitational data showed a tightening of localized mass distribution patterns, as if subsurface structures were reconfiguring into a more compact and controlled arrangement. At the same time, electromagnetic sensors detected structured oscillations that matched the timing of earlier hexagonal light emissions. And then came the most concerning detail. The resonance detected in Orion's hull intensified. What was once a low-frequency vibration became a sustained harmonic pulse, steady and measured, as though the spacecraft was now embedded within a larger oscillatory system. Engineers confirmed that the frequency was not degrading or scattering over distance, it was being maintained. That meant the source was not passive, it was regulating itself. At this point, the working assumption in mission control shifted again. The Hertzsprung basin was no longer being treated as an isolated anomaly or even a networked system. It was now being considered a dynamic interface, something capable of interacting with external objects in real time. And Artemis II was inside its influence range. This interpretation gained further support when spectral analysis of the lunar surface revealed a new layer of complexity. Beneath the previously detected energy emissions, scientists identified consistent isotopic signatures that did not match any known natural lunar composition. These signatures were stable, organized, and distributed in patterns that resembled engineered segmentation. In other words, the subsurface structure was not uniform. It was compartmentalized. Each region appeared to respond differently to external inputs, suggesting specialized functional roles within a larger integrated system. This finding forced researchers to revisit older lunar models with new scrutiny. Historical Mascon data, once considered well understood, now appeared incomplete. Subtle inconsistencies in density mapping aligned too closely with the current anomalies to be dismissed as coincidence. What had once been categorized as measurement error now looked like low-resolution observation of a far more complex structure. And this is where the interpretation became increasingly difficult to contain within traditional geological frameworks. Because if the Moon contains a compartmentalized internal system capable of coordinated energy output, gravitational modulation, and resonance-based interaction, then it cannot be described as inert.